In 1937, Mercedes-Benz created the M125, a 5.7-liter supercharged straight-eight that produced 646 horsepower on the test bench and dominated Grand Prix racing for one season. This is the story of the most powerful racing engine of its era, built when regulations permitted unlimited displacement under a 750-kilogram weight limit. Engineers at Mercedes' Untertürkheim facility extracted 114 horsepower per liter from this engine, values not exceeded until turbocharged Formula One engines appeared in the early 1980s. The M125 powered Rudolf Caracciola to the 1937 European Championship, while Hermann Lang crashed into spectators at Brno, killing 2 people. Crisis and reorganization. Mercedes-Benz withdrew from Grand Prix racing in August 1936 after a catastrophic season. Auto Union dominated with 6 victories, while Mercedes managed just 2 wins before pulling out. The W25 car suffered from fundamental engineering problems that made it uncompetitive against Auto Union's mid-engine design. The company's racing structure had become ineffective. Multiple departments operated without proper coordination between the design office, experimental department, and racing team led by Alfred Neubauer. Chief designer Max Saylor managed the central design office with separate chiefs for engine and chassis work, while Fritz Nallinger's experimental department handled construction and testing. Communication failures between these groups prevented quick responses to racing problems. Mercedes established a new Rennabteilung in late 1936 to bridge design and racing operations. Rudolf Uhlenhaut, a 30-year-old production car engineer, took charge of this racing development department. Born in London on July 15, 1906, to a German father and English mother, Uhlenhaut had joined Mercedes in 1931 after graduating from Munich University. He had tested road cars extensively on the Nürburgring, but never worked on racing cars. Uhlenhaut drove the failed W25 cars himself during August 1936 testing at the Nürburgring. Despite never having driven a racing car, he proved exceptionally talented behind the wheel. His analysis identified critical problems. Suspension was too stiff, chassis flexed under braking, and the rear de Dion axle bent 7 to 10 centimeters during heavy braking. During one test session, a wheel detached at high speed, yet Uhlenhaut continued driving on 3 wheels as if nothing had happened. After Auto Union won the Swiss Grand Prix emphatically, Uhlenhaut recommended Mercedes abandon the 1936 season entirely. The team withdrew to focus completely on developing a new car for 1937, giving them 5 months to design and build the W125. Engineering the M125 straight-eight. Mercedes faced a fundamental decision about the new engine's architecture. Previous M25 engines had reached 4.74 liters and 490 horsepower, but proved unreliable when enlarged further. Engineers tested a 5.58-liter V12 weighing 295 kilograms, but this configuration placed too much weight on the front wheels and compromised handling. The team returned to an inline-8 layout, the M125, with substantially increased cylinder spacing. Previous M25 engines used 95mm spacing between cylinders. The M125 employed 104mm spacing, allowing bore and stroke dimensions of 94mm by 102mm. This undersquare configuration, typical for the period, displaced 5,662.85 cubic centimeters. The engine construction followed established Mercedes practice. 2 blocks of 4 cylinders each featured steel-forged cylinders with water jackets and ports welded in sheet steel. The cylinders spigoted into an aluminum barrel-shaped crankcase. The crankshaft ran in 9 main bearings of split roller type manufactured by SKF, with big ends using the same roller bearing design. Moly-supplied pistons, while connecting rods, were fully machined H-section components made from nickel-chrome steel with plain bronze bush gudgeon pins. A dry sump lubrication system employed a battery of gear-type oil pumps and a front-mounted oil radiator, which stored oil in a separate tank rather than under the engine, allowing the power plant to sit lower in the chassis. The cylinder heads featured hemispherical combustion chambers with 2 inlet and 2 exhaust valves per cylinder at a 60-degree included angle. Exhaust valves contained mercury for cooling purposes. Two gear-driven overhead camshafts operated the valves through shim-adjusted tappets. The heads were not detachable, requiring complete removal for major service work. Mercedes initially configured the Roots-type supercharger to blow air into the carburetor in their established fashion. The blower ran at twice engine speed and operated at 12 to 14 pounds per square inch boost pressure. Later in 1937, engineers reconfigured the system to a suction-type arrangement where the supercharger drew mixture from the carburetor, proving more effective for power delivery. The engine weighed 222 kilograms, approximately 30% of the car's total weight. Power output varied between individual engines, with race trim producing 560 to 595 horsepower at 5,800 RPM. Test bench measurements recorded peaks of 637 to 646 horsepower. At just 2,000 revolutions per minute, the engine developed 245 horsepower and 643 pound-feet of torque. Extreme fuel and operating characteristics. The M125 consumed 1 liter of fuel per kilometer during racing. Mercedes specified a custom mixture of 86% methyl alcohol, 4.4% nitrobenzol, 8.8% acetone, and 0.8% sulfuric ether. Different fuel formulations were prepared for specific circuits, with the Italian Grand Prix mixture containing 88% methanol and 8.8% acetone with trace substances. This aggressive fuel chemistry enabled the compression ratio and power output, but created operational challenges. The engine achieved a specific output of 114 horsepower per liter, and when calculated against the 1936 750 kilogram regulation weight limit, this corresponded to a theoretical power-to-weight ratio of 1.16 kilograms per horsepower. These figures remained unmatched until turbocharged Formula One engines appeared 4 decades later. The M125 exhibited peculiar running characteristics that troubled drivers and mechanics. The engine ran rough under normal operation, creating significant vibration throughout the car. However, if the engine suddenly began running smooth, mechanics knew the crankshaft was beginning to crack. This counterintuitive behavior meant smoothness indicated impending failure rather than proper function. Engineers at Untertürkheim could extract different power levels depending on circuit requirements. The engine produced 592 horsepower at 5,800 RPM for the Italian Grand Prix at Livorno on September 12, 1937, while other configurations reached 645 horsepower. 8 different transmission ratios were available, along with 2 rear wheel sizes of 7.00-19 and 7.00-22 inches. A single dry plate clutch mounted to the engine flywheel connected to a 4-speed constant mesh gearbox. This design replaced the sliding mesh transmission of the M125, providing better reliability. The gearbox, ZF limited slip differential, and final drive formed an integrated unit mounted to the rear crossmember rather than the engine. The complete W125 weighed 1,097 kilograms ready to race, including 240 liters of fuel, 7 liters of water, 9 liters of engine oil, and 3.5 liters of transmission oil. Without driver, the car weighed 1,021 kilograms. Revolutionary chassis development. Uhlenhaut's testing of the W25 revealed that Mercedes had approached suspension design backwards. The old car used stiff springs with minimal damping, causing wheels to lose contact with the road surface. Uhlenhaut reversed this philosophy completely, specifying soft springs with long travel and stiff dampers. The W125 employed the first tubular frame in Mercedes Grand Prix car history. Oval section nickel chrome molybdenum, steel tubes of 1.5 mm wall thickness provided torsional rigidity far exceeding the previous ladder frame. 5 cross tubes braced the structure, creating a chassis that didn't flex under braking loads. Front suspension used unequal length double wishbones, measuring 8.45 inches upper and 10.59 inches lower. Coil springs with substantially more travel than the W25 allowed wheels to follow road undulations. Mercedes specified both hydraulic and friction shock absorbers initially. though some races used hydraulic dampers alone. The rear suspension employed a de Dion tube with both halves forged and machined from a single piece of nickel-chrome molybdenum steel. This design maintained constant camber while allowing vertical wheel movement. Two channel section radius rods provided fore and aft location, while torsion bars, 33.2 inches long and 0.67-inch wide, supplied the spring medium. Lockheed hydraulic brakes used a two-leading shoe design with Ferroto linings, alloy shoes, and drums, with steel liners shrunk into the aluminum. The wheelbase measured 2,798 millimeters, with a front track of 1,473 millimeters and rear track of 1,412 millimeters. The aluminum bodywork remained unpainted in bare silver, continuing the Silver Arrows tradition. German racing colors were officially white, but teams stripped paint to save weight, revealing the aluminum underneath. For the ultra-fast Avis race on May 30, 1937, Mercedes fitted streamlined bodywork that increased top speed by 25 kilometers per hour compared to the standard open-wheel configuration. Debut victory and early season dominance. The W125 made its racing debut at the Tripoli Grand Prix in May 1937 with 4 entries. Hermann Lang won his first Grand Prix motor race, giving the W125 victory in its first competitive outing. This marked Mercedes' first win over Auto Union since May 1936, validating the complete redesign approach. Avis presented a unique challenge with its 19-kilometer circuit, consisting of 2 long straights joined by curves at each end. Mercedes entered 2 cars, a streamliner for maximum straight-line speed and a standard car driven by Richard Seaman as backup. The streamliner led early, but retired on lap 3 with gearbox failure. Hermann Lang averaged 261.7 kilometers per hour during the race, setting records that stood for decades. During Avis practice, Lang's streamliner with wheel covers reached 390 kilometers per hour when trapped air under the car lifted the front wheels from the ground. Lang kept calm and gradually brought the wheels back down. Mercedes removed the wheel covers for the race itself. At the Eiffelrennen held at the Nürburgring, Mercedes entered 5 W125s, including one driven by Christian Kautz, fitted with the new suction-type supercharger system. The modification improved mid-range power delivery compared to the pressure carburation system. Following this success, Mercedes retrofitted all W125s with suction carburation by mid-season. Mercedes split their entries for the next race week. 2 cars went to America for the Vanderbilt Cup, while 3 competed in Belgium for the first European Championship round. Richard Seaman finished second in the Vanderbilt with the suction supercharger, confirming the system's effectiveness. Third and fourth places came at the Belgian Grand Prix. The German Grand Prix on home soil saw Mercedes triumph as Rudolf Caracciola took his first victory of 1937 with Manfred von Brauchitsch second. At Monaco, positions reversed with von Brauchitsch winning and Caracciola second. Christian Kautz took third place, giving Mercedes a complete podium sweep. Tragedy and championship victory. The Coppa Acerbo in Italy brought disaster when Richard Seaman crashed into a house at high speed and completely destroyed his W125. The impact demonstrated the extreme velocities these cars achieved even on street circuits. Only von Brauchitsch and Caracciola could start the race for Mercedes. Seaman took over from Caracciola mid-race despite lacking his own car. The shared W125 suffered an engine fire during Seaman's stint, flames emerging from the engine bay. Despite this mechanical drama, the team finished 5th, while von Brauchitsch secured 2nd behind Rosemeyer's Auto Union. The Swiss Grand Prix at Bremgarten saw Mercedes return to dominance. The 7.28-kilometer circuit through forested areas suited the W125's power and chassis balance. Caracciola dominated from the start, demonstrating the M125 engine's reliability. Hermann Lang finished 2nd with von Brauchitsch 3rd. This victory solidified Mercedes' championship position with 1 round remaining. The final European Championship round at Livorno provided a dramatic conclusion. Caracciola and Lang battled throughout, trading positions as they lapped slower competitors. The 0.4-second margin was one of the season's closest finishes. Caracciolla's victory secured both the race and the 1937 European Championship, his second after 1935. Von Brauchitsch retired from mechanical problems, but his season secured second in the championship. The Masaryk Grand Prix in Czechoslovakia on September 26 gave the W125 its final victory. The Brno circuit's 29.142-kilometer layout through public roads created one of the season's most challenging and dangerous venues. Caracciola won with von Brauchitsch second and Seaman third, giving Mercedes another complete podium sweep. However, the race became infamous for tragedy when Hermann Lang crashed into spectators on lap 5. Mechanical failure or driver error sent his W125 off the circuit at high speed directly into the crowd. The impact killed 2 spectators outright and injured 12 others seriously, starkly highlighting the dangers of unlimited power formulas producing cars capable of speeds exceeding 300 kilometers per hour on circuits with minimal safety barriers separating cars from spectators. The crash raised serious questions throughout the motorsport community about whether racing cars had outpaced safety measures. Spectators stood dangerously close to tracks with only rope barriers or small wooden walls for protection. The M125's 646 horsepower, combined with lightweight and the W125's minimal body protection, created performance that fundamentally exceeded safety infrastructure capabilities of the time. This incident, along with numerous other serious accidents during the 750-kilogram Formula era, ultimately contributed to the regulatory changes implemented for 1938. The final race came at the Donington Grand Prix in Britain. Rosemeyer's Auto Union prevailed in his final major victory before his fatal crash in January 1938. Von Brauchitsch finished second and Caracciola third in W125s. 2 other Mercedes entries failed to finish with mechanical problems. British-era cars were completely outclassed, unable to match German power or reliability. Caracciola finished as European champion with 13 points under the era's scoring system, where lower scores were better. Von Brauchitsch took second with 15 points, while Kautz and Lang both scored 19 points. Mercedes drivers occupied the top 4 championship positions, demonstrating the W125's complete dominance throughout 1937. Legacy of the most powerful racer. Regulations changed for 1938, replacing the weight limit with a 3,000 cubic centimeter capacity limit for supercharged engines. The W125 could not compete without major modification. Mercedes developed the W154 with a 3.0-liter supercharged V12 designated M154, producing 425 to 474 horsepower initially, with later 2-stage supercharged versions reaching 476 horsepower at 7,800 revolutions per minute. Each M154 engine cost 89,700 German Reichsmarks, equivalent to nearly $1 million today, demonstrating the enormous resources Mercedes committed to racing. The M125 achieved performance figures unmatched in Grand Prix racing for 3 decades. The 646 horsepower peak and 114 horsepower per liter output represented engineering achievement contemporary racing couldn't approach. Large-capacity American V8 engines in Can-Am sports cars finally reached similar power in the late 1960s, requiring 7- and 8-liter aluminum blocks to match what Mercedes achieved with 5.7 liters in 1937. In Grand Prix racing, which became Formula One after World War II, the M125's power wasn't exceeded until turbocharged engines appeared in the early 1980s. Renault's EF-type engine, BMW's legendary M12/13 4-cylinder, and Ferrari's turbocharged V6 finally surpassed the M125's output 5 decades later using advanced metallurgy, electronic fuel injection, and sophisticated turbocharging technology unavailable to 1930s engineers. A modified W125 record wagon achieved 432.7 kilometers per hour in land speed record runs. This specialized car used a DAB V12 engine with bore and stroke of 82 by 88 millimeters, displacing 5,176.75 cubic centimeters and producing 726 horsepower at 5,800 RPM. However, its weight exceeded the 750 kilogram limit, preventing Grand Prix use. Standard W125s reached speeds over 300 kilometers per hour during racing, particularly at Avis, with streamlined bodywork. The 750 kilogram formula of 1934 to 1937 created an unlimited formula similar to Can-Am racing in the 1960s and 1970s. This minimum weight regulation allowed German teams, supported by government subsidies and military technology access, to build cars far more powerful than regulators intended. Mercedes and Auto Union pushed engineering boundaries beyond what safety measures could accommodate, as the Brno tragedy demonstrated. The M125's peculiar characteristic of running rough when healthy but smooth when the crankshaft was cracking illustrated the extreme stresses these engines endured. Drivers and mechanics learned to listen for rough running as a positive sign. When vibration disappeared, crankshaft failure was imminent. This counterintuitive behavior resulted from extreme forces in the reciprocating assembly at high RPM. The combination of supercharging at 12 to 14 psi boost, aggressive fuel mixtures containing methyl alcohol and acetone, and high compression ratios pushed 1930s metallurgy to absolute limits. Roller bearings helped manage extreme loads, but crankshafts still developed cracks under sustained high RPM operation. Engines required complete rebuilding between races with thorough inspection of critical components. Rudolf Uhlenhaut's contributions extended far beyond the W125 program and influenced automotive engineering for decades. His philosophy of soft springs with stiff dampers became standard for Mercedes sports cars and influenced racing design generally. Modern racing cars still follow this fundamental principle that Uhlenhaut proved at the Nürburgring in 1936. He continued developing Mercedes racing cars through the 1950s, including the 300 SLR that Stirling Moss and Dennis Jenkinson drove to victory in the 1955 Mille Miglia at record-breaking average speeds. The M125 conclusively demonstrated that Mercedes' traditional front-engine approach could overcome Auto Union's innovative mid-engined advantage through meticulous attention to chassis dynamics and precise power delivery characteristics. Uhlenhaut's reversed suspension philosophy, combined with the M125's extraordinary 646 horsepower output, created the most dominant Grand Prix racing car of 1937. The engine powered Mercedes drivers to 7 major race victories over one season before fundamental rule changes made it completely obsolete. Its remarkable specific output of 114 horsepower per liter and theoretical power-to-weight ratio of 1.16 kilograms per horsepower, based on the 1936 regulation limit, remained performance benchmarks for decades afterward. The M125's profound influence on engine design principles and suspension engineering philosophy shaped motorsport development through the entire turbocharged era and beyond. Though the tragic human cost of unlimited power formulas became painfully clear at Brno, where Lang's crash killed 2 spectators and injured 12 others. The M125 remains the definitive benchmark for pre-war racing engine achievement and a testament to 1930s engineering ambition.